this video, I'm going to show how to calculate the RTRR based on some EMVs. So the RTRR is going to be the EMV divided by the standard deviation. So first I'm going to need to calculate the standard deviation, and it's a little bit tricky. I'm going to start here by focusing on this term, x minus the EMV. So I would have the x for, say, A minus the EMV. So that would be just focusing on one decision at a time. I'm going to black this out. Let's focus on decision to buy at A. What I would be doing is the payoff would be my x value minus the EMV for buying at A only. Similarly, I would do this for the outcome B. So that would be the payoff associated with B minus the EMV. Now this value gets squared, so there's no reason why I couldn't have just put brackets around this and squared it to the power of 2. And I'll do the same thing over here. Now, one thing to note is that each of these terms, the x A minus EMV all squared is going to get multiplied by its probability of 40%. And the 57.76 here is going to be multiplied by the probability of 60%. So, and these are going to get added. That's what the summation sign means. So we're doing another sum product to get that variance. So to get my variance, which is the squared standard deviation, I would take the sum product of these two values against these probabilities. And because I'm going to do this through a whole table, I'm going to lock in the references for the probabilities, the 40 and the 60%. I'll be able to drag that down. So now I have the variance. From that, I can get the standard deviation, which would be the square root, so you write squirt almost, square root of that variance. And now I have the standard deviation. The final step to calculating the RTRR for this decision would be to take the EMV for this decision, divide it by that standard deviation. And there I have the RTRR for this decision. Now I need to repeat this for the other decision. So I would go through them one by one, which let's see if I can actually do that by just dragging things down. So let's first check our x A minus EMV. So for the decision to buy at B, this should be the -12 minus 3. And indeed, we have that. All the way down, we can see that that is the case. So that works for these. Double check that as well. We got the XB minus the EMV for the decision of buying nothing. Now variance was our sum product of these probabilities against these row values. So that should be good to drag down as well as my standard deviation being the square root of the neighboring cell. That looks fine as well. And finally the RTRR, we can see that these are the EMVs divided by the neighboring column of standard deviation. Now it's important to note here that the RTRR for buying nothing is you get an error message, and that's because we're dividing by 0. Because there's no variance, there is no RTRR. We would really say that this is not applicable. This would be our optimal decision, however. So sometimes I would like to write 0 here, just even though that is not correct. There is no RTRR value, but we can write 0 there to compare to our other options, as we do want the highest RTRR, preferably positive. If our RTRRs are all negative, we would choose to buy nothing instead. Now, what we're going to do from here is we are going to choose the highest RTRR because that is our optimal decision. It is the lowest risk. So I'm going to take the maximum of these RTRRs which is 0.88 million. So that's going to be my optimal RTRR value. And that is associated with what decision will I go up? And you can see that it's related to buying at both A and B, which is our lowest risk logically as well.